All right, Assalamu alaikum and a very good afternoon, everybody. Welcome to another session of Agriculture, IoT and Big Data e-workshop series, collaboration between Faculty of Agro-Based Industry, University of Malaysia Kelantan and World Resource Webinar. My name is Muhammad, a lecturer at the Faculty of Agro-Based Industry, and I will be the moderator for today's session on machine learning and AI or artificial intelligence in agriculture, and e-workshop series on urban farming and cloud computing and IoT or Internet of Things. So for this session, for this session, we are going to have two distinguished speakers to talk about two different topics. The first one is going to talk about machine learning and AI in agriculture, and the second one is going to talk about urban farming, cloud computing, and IoT. So for this session, for the first one, we're going to start with topic of introduction to machine learning. They will be from 2 until 3 p.m. And then after that, we continue to the second session with urban farming and cloud computing and IoT until 4 p.m. So if you have any questions or it's something in your mind that you don't understand, you'd like to know more, just feel free to type on the chat section on Zoom, or you can just unmute yourself and start asking questions. So all right, so before we start, just a little bit introduction about what is machine learning. So basically, I believe that everybody ever heard about artificial intelligence. So basically, machine learning is a part of artificial intelligence. And the special thing about machine learning is that it can predict the future. Okay, it can predict the future or classify information to help people in making necessary decisions. Okay, so this machine learning, they use algorithms or use historical data as input to predict new output values. I believe that you are familiar with Google's. If you ever use Google services, for example, like Gmail, Google Maps, Google Search, then you are using machine learning by either you realize or not. And then if you also realize, Facebook also use a lot of machine learnings in a lot of the operations. That's why sometimes they can provide with they know what type of ads they want to show to you, because they use machine learning. They learn about your activities and so on and so forth. So that's where we're going to talk about today, but it's basically more on agriculture. Okay, so I'm not going to talk more about this topic. I will let this our speaker for today, Dr. Varalatchoumy, to continue. So I believe that Dr. Varalatchoumy is here today with us. Hello, doctor. How are you? I cannot hear you, doctor.
Yeah, sorry. I'm fine. Thank you.
Oh, sounds perfect. Welcome.
Hoping the same from your end.
Okay, so before I give hand over the session to you, I would like to give a little bit introduction about Dr. Varalatchoumy, our speaker for today. So Dr. Varalatchoumy is an associate professor in the Department of Computer Science and Engineering at Cambridge Institute of Technology, Bangalore, India. So she has 15 years of teaching experience and 8 years of experience as researcher. And then one of the things that I realized in the document that she shared with us is one of her important research has contributed towards detection of malignant tumor at the very early stage. I believe that is very, very impressive. And she has more than 20 international journals, publications, 5 patents under her name, and also contributed as a guest editor for Springer Journal titled Systematic Artificial Intelligence. So I believe that she is the right person to talk to us about machine learning and artificial intelligence. So without any further ado, I would like to welcome Dr. Varalatchoumy. The floor is yours.
Thank you, Mr. Mohammed. So I'll just share the screen. Hope my presentation is visible. Yeah. Is the presentation visible?
Yes, if you can put it into a slideshow.
Yeah. Sure. I'll make it. Is it fine now?
Not yet.
Okay. For me, it's visible. Hope it has moved to the slide show mode.
I still view on the
Just
presentation slide. There is not a slide to view yet.
yeah, just
Okay. No, okay. It was okay just now.
yeah. Now is it visible?
Yes. Perfect. All right.
Yeah. Okay. Thank you. So I'll start. So first and foremost, thanks a lot to UMK and the faculty members for having provided me an opportunity to share my knowledge about AI ML in agriculture. Thanks for the topic also. It was quite interesting and it has aided me to do a lot of new surveys in this field. Fine. So gone are the days wherein we feel like agriculture is only for one sector of people, right? Like only few people will be involved in agriculture. And nowadays, the buzzing word is smart agriculture. Everywhere we see people talking about smart agriculture. So what about smart agriculture and why we get into smart agriculture and what aids us, to move into smart agriculture? So basically, when the whole process of agriculture is going to be carried out using certain technologies, name it like Internet of Things, the sensors, we make use of lot many sensors and we make use of the location systems. And basically, in the higher end, if you see, if you are able to make use of robots and artificial intelligence completely, then we call the whole process of agriculture has moved into a smart agriculture. So why people prefer to move into smart agriculture? Why the traditional agriculture is, seen a slight burdening? And what is advantage? What we gain when we move into smart agriculture? So the main goal why we move into smart agriculture is to increase the quality and the quantity. So these two are the buzzwords now because we need to concentrate upon how well we can get the profit, we can get benefited through this agriculture process. The crops has to be sold appropriately, farmers has to get benefited and it should be in tremendous level. So the quantity and the quality of the whole process is very important for us. So in order to improvise, in order to get the best profit out of it, mainly we move into smart agriculture. And the best part of this is using our various technologies, we are able to get things done in a highly precise manner, very perfect, flawless, truly speaking. An extra important thing is the 24/7 control what we can get about our farm, the field, the crops, everything. And the third important thing is several resources are being saved to a great extent, be it water, the fertilizers, how much the quantity, everything. Top of all is nothing but the human labor. So we can have very minimal labor effort, okay, and we can get the best yield. That's the main reason we move into smart agriculture. So before I move into the actual technological stuff, I wish to highlight one thing. Most of the slides, what I've analyzed and added over here, from the very next slide, I can tell each and everything has a research problem behind. So the several papers has been surveyed and several real-time problems and how people have sought out the solution for that. I've analyzed lot many things and then I've put into it. So people who are aiming to pursue your research, you will have a lot of key insights into this. And apart from that also, if you wish, if you have lot many queries, as Mr. Mohammed was mentioning, if you have lot many queries, feel free to share to me over here, or I would also share my mail ID. Anytime you can get back through the mail. Fine. So what were the problems faced in the traditional agriculture? Till date, what are the problems being faced? Because we cannot tell like smart agriculture is common in all geographical locations and in all countries. It is still in the developing stage. So what were the problems in the sense we have basically, if the weather is not forecasted properly, okay, if the weather prediction doesn't have properly, it's a great loss. Next thing is the aging workforce. Many people feel like it's a very routine work and almost the same thing, and they feel it is not that profitable. So people keep moving towards the urban cities and they try to move out of these agricultural practices and farming, which is again a greater loss for us. And third important thing is unpredictability through all means. For example, starting from the seeds, which are the best ones, through to the level of the fields like the soil, whether it is perfect or not, Lot many things has to be predicted perfectly. So the unpredictability is another major problem. Next one is to what extent the resources are needed. As I was just mentioning in the previous slide now, each and everything over here is a resource. So all these resource has to be, perfectly judged, and we need to identify whether we have the appropriate resources before we start our whole process of the agriculture. Fine. And of course, you might have a question. What about people's experience over here? Pretty much. Farmers' current experience, their level of knowledge with respect to this agricultural thing is something which is also helping us. Apart from the theoretical studies, their experience knowledge is something which is helping us to develop our own machine learning systems. Agreed. But when it comes to the task force in the sense a set of people, how many people are going to be involved, the tremendous job behind it, the sternness job behind it, it's going to be easy when we move into smart agriculture. Fine. So how well artificial intelligence is going to help us? What are the different things AI can do in order to face all the farming challenges, and how well it is going to support us? So first and foremost, if you see, we have lot many techniques, artificial intelligence techniques, which will help us to predict. Let me start from the top left corner from over here. So the crop yield prediction and price forecast. So if suppose I'm planning to go ahead with a particular a particular crop, okay, whether that crop is suitable for that particular season, to what extent people would prefer it, and what would be the price when it comes to market. It is like few months we are going to take for the whole process. So when it comes to market, what would be the market demand? So to that extent, we can do the predictions, forecasting of lot many things. Next one is intelligent spraying. This is something which is really putting all of us into trouble now. The herbicides, the insecticides, everything is being spread across over all the crops, which is actually not needed. The moment we fix some artificial intelligence sensors, and truly speaking, when we start with developing small projects, we will have our small sensors for this, which will sense the exact weeds over there, the location where it is not the actual crop, and through the small sensor itself, we can predict it, and exactly in the location where the weed is present, in that location alone, we can go for spraying the herbicides or the insecticides, which will save the human's life. Basically, finally, our life is into trouble. So it will help us to save the human life and avoid all the side effects and those problems. Next one is predictive insights. Lot of sensors, and through the sensors input. See, for example, I place a sensor to predict the condition of a soil. So that sensor will give me a lot of data. From the sensor, I'll be deriving a lot of data, and that data will be fed as input to my algorithm. So through my algorithm, the machine learning algorithm, I'll be able to predict whether the current time, is it the right time to sow? So obviously soil alone is not sufficient. We have to get input from the weather insights we need to take. Next, we need to take insights about, as I was mentioning, after how many months it's going to get into the market, what is the current demand for the crop. These are all the data for us. So when all these data are put into an algorithm, we can process this data, and easily we can get to know whether this is the right time to sow this particular seed, and whether we'll have the actual benefit. So these are all the benefit. And apart from that, if you see, we can also have the agricultural robots. So few countries have already implemented it, wherein instead of using humans to do the harvesting, we have the robots. So when we see here, it's very simple. We just tell like agricultural robots. No, when we start developing even a small robot, okay, for say, just a small particular mission, it's nothing but the robot's eyes are nothing but the camera, which is going to capture what is happening right in front of it. That input is going to be fed into an algorithm. Again, the processing happens, and then it is going to carry out some particular action. So those particular robots, if you just see the two cameras, if you visualize a robot's eye as two camera, how well the image is being captured and how to process the image itself is a particular domain. That is the image processing domain itself. It's an ocean. So like that, each and every component of a robot, how do you make a robot to move in a particular direction? How you make its arm to operate? So many things. So as I told, each and everything itself is a particular research topic, not just a topic, an ocean of research topics within. So agricultural robots have already been developed, which can be used in order for harvesting. Thereafter, if we see, we have crop and soil monitoring. All of us know this. So we have lot many sensors which can be fixed to the crops as well as to the soil in order to predict lot many things. And finally, the disease diagnosis. One of my colleague had worked on this disease diagnosis, wherein the plant diseases, the surface of the plant will be having certain types of diseases. Many times we miss the diseases which is like below the plant, okay, the leaf and everything. So those things also has to be predicted in order to get to know to what extent the insects or some other factors are spoiling the particular quality of the crop. So all this can be done without human interference. That is the best part of it, artificial intelligence. Just imagine you have a farm wherein all these things are being carried out automatically. You just have a system right in front of you, which is going to feed in all the data to you, giving you all the prediction. So this is how we visualize our smart farming. So artificial intelligence, it is going to help us maybe to solve all the farming challenges. So decision makings are going to be far better, right? The predictive analytics is going to be the game changer. So we are going to make use of machine learning algorithm to do the predictions prior, ahead of time, and in a precise manner. Very important. So we can just visualize the farmers having one application in their hand. They need not even visit their field. They just have everything in their hand. That application tells them everything. Your field right now, this is happening. This has to be done. That is also taken care. For example, the herbicides, the insecticides has to be sprayed. It was sprayed in this particular location and done. Okay, that job is also done. The seed has to be sown. That is also sown. So to this extent, starting from analyzing the marketing demand, forecasting the prices, as I was mentioning, everything can be taken as data, processed, and then given to the farmer at ease in their hand. So it is to this extent we are expecting the revolution to happen. Yes. So what is the best part of your artificial intelligence? Mainly the cost saving. So it is going to avoid lot many problems which farmers are facing currently. So if we start working on the various aspects of our smart agriculture, if you see, with very minimal resources, we can help the farmers to grow more crops. That is the best thing. We can support them to get the maximum yield with a very, very minimal input cost. That is next important thing. Beautifully, we can help them to manage the soil, right? They will be getting all the information about their soil, I mean their field, their crops, everything. So what is last important thing over here? The advantage is the innovative farming practices. So gone are the days wherein we are going to make use of the field. See, the picture what I've shown above. We have a field wherein obviously we go for carrying out our agricultural tasks, we harvest and do things. But now it's all changed. There is no requirement for any field as such in order to carry out the agriculture. We have the concept called as vertical agriculture, wherein in a particular space, there are some facilities being made like this. So plants are being grown in locations in this way. So there is nothing like you have to own a piece of land to carry out your agriculture. Again, in this vertical agriculture also, we have sensors, everything fixed to it. So beautifully, we can manage the whole task. So the precision agriculture, the vertical agriculture, these are all the buzzwords now. Yes. And the most important thing is the labor shortages. You need not even wait for human support. We have nowadays the driverless tractors, which is again going to sense through the camera. It checks out what is a field, it visualizes, and immediately it starts, it moves, it carries out its task without any human interference to that extent. So next is we have our fertilizing system. You don't want any human being to go literally stand in the field and then spray the insecticides. Not needed at all. That is called as a smart spraying. As I was mentioning, the vertical farming softwares are now quite common. So you have the complete app which can be inbuilt in your mobile. You just choose which particular plant, that's all. And immediately vertical farming, the supervision is taken care. So very important thing is the artificially intelligent driven tools through our machine learning algorithms at the back end, they are considered to be very, very faster, harder, and very, very accurate. So this is where exactly our research challenges will come, the precision. When we start, for example, I choose a research problem like I want to monitor all the soil related parameters. The soil, how loose it is, how tight it is to carry out. Next one is how easily it will get affected by the weather conditions. Suppose heavy rain, what will happen? The soil erosion. Is there more chances of soil erosion? And how healthy the soil is, how much water it is going to consume. Not many parameters. If I'm able to just fix few sensors and I'm able to develop an algorithm which will be capturing this data in real time continuously, right? And it keeps on giving me the feedback. It gives me the input. If the soil is in this condition, you can go ahead with this work. That accuracy, how precise, to what extent I can depend upon my algorithm in order to carry out my task. And obviously we cannot come out with any system, which is like 100% perfect. It will become an ideal system where though it is 99% accurate, how can that 1% need not be 99.999, that point, not 1% error, how well it can be handled without any loss. This will be our research, and the projects, the various real-time projects what are being carried out are all focused towards in this direction. Fine. Okay. So as I was mentioning, you can see the pictures over here. I thought of showing it in a picture. So you have lot many machines now, strawberry picking machines. You have your, machines which will harvest the apples and everything. When we see it as a machine, it is very simple, friends. You just see one robot here. Okay, what is this robot going to do? Something goes there, it picks that particular fruit, it plucks it. It's so beautiful. But just imagine a human has to be literally, like converted to a machine. What you visualize through your eyes, when you see, yes, this fruit is ready for harvesting. All the fruits doesn't get ripened at the same time. All the fruits cannot be harvested at the same time. Harvesting cannot happen in one shot. So it is very important. This particular hand, if you see here, right, how perfectly it goes to that location, how it plucks it, how the camera captures that particular image, how that image is being processed. Is the environment the same? No. For example, here if you see, there is very less, the image quality is only so good. Okay, this fruit can be visualized more better manner in the camera. Suppose it is too foggy, the environment itself is blurred. How the camera can get to know that fruit is ripened? So all those external things which is really affecting the quality of the image is going to be called as a noise. So all those noise has to be removed. Then this data has to be fed in. Then using certain parameters, what we have fed it into the machine, it has to compare. Then it will identify, okay, this fruit is ready for harvesting. I can pluck this particular fruit. Right. So it's like a lot of techniques and technology, not only machine learning, not only artificial intelligence. If you ask me, it is complete computer vision, which is inside it, a particular robot. So lot many algorithms and techniques are available, dear friends. In this session also, I'll be mentioning several algorithms to you. You can also do a survey. You can get to know how many algorithms and techniques can be used. To start with, you can start with small project. For example, just with the camera, how well we can capture the image, how we can identify whether the fruit is ready for harvesting or not. This can be a small project to start with. Like this, step by step, we can make a move. Okay. So not many machines are available, readily available, and people are using it in various places. Right. So now, slow and steadily, when we move into the technical aspect. So as we know, whenever I mention it like artificial intelligence, it is nothing but machine learning. So machine learning is a subset of AI. Without ML, AI doesn't exist. When we tell a system has become artificially intelligent, it is not naturally intelligent. It is able to work, it is able to think and work like a human, which means intelligence has been fed into it. It is being directed to do something like a human. So how does that happen is through the machine learning algorithm. Put in simple terms, what is machine learning? We are trying to make a machine learn like a human, for which we are going to make use of certain algorithms. So through this machine learning only, any particular system is going to become an artificially intelligent system. So we'll be checking out in the following slides, we'll be coming across various algorithms which can be used in order to carry out the task, whatever I mentioned till now in smart agriculture. And as I was mentioning, the important data sources for ML, machine learning or artificial intelligence is the most critical thing is the input data. If the input, see, to what extent you will be able to get the input data determines efficiency of your system. If you're able to get tremendous input data, if you're able to handle that input data properly, handling means what? You as a developer, you should be aware of which data is needed, which is not needed, because you will be getting lot much information, lot much data through the sensor. What is needed alone, you need to take it for that particular task. Next, whether it is redundant, too much data is present, you have to remove it. Whether it is correct, the input data itself, if it is not correct, then obviously your result is not going to be correct. So whether it is in the proper format, whether that is the data what you actually need, whether that is precise. So all this as a developer, you should be able to get it done. Then you can choose the appropriate algorithm in order to process this data. So the critical thing in any machine learning algorithm or system is nothing but the input data sources. So if the sensors, or it can be through your satellite images, or it can be through your the drones can get the input for you, anything. But finally, see to that data is being processed properly in order to start your algorithms. Before applying the algorithm into it, it is actually called as a pre-processing stage. So we need to process the data appropriately, then we need to start working. So this is something very basic. Fine. So what are the various activities in which we can apply the various algorithm? What all we discuss now can be put into 3 stages. Pre-harvesting stages in the agriculture, harvesting stage, and then the post-harvesting. As I was mentioning just now, in the pre-harvesting stage, all these things has to be sensed properly. The soil condition, the seed, how good it is. We'll be seeing in the following slides. The environmental condition, the weed detection, disease reduction, all this has to be taken care. We have many algorithms to do this. Similarly, harvesting and post-harvesting. Many of us can think agricultural work stops with harvesting. No, dear friends. It starts post-harvesting according to me, because it's not just the process of agriculture. How well we take it to the market, how well it reaches the people. We don't waste much during harvesting. Okay, the best of the goods, how better it reaches the people, how they receive it, and how well we can store it. It's not like whatever we harvest now, we can immediately sell it. We need to, store it properly. So the shelf life, everything matters. So all these 3 operations, pre-harvesting, harvesting, and post-harvesting, are very critical in order to get the best out of our smart artificially intelligent system. Right? Okay. So as I was mentioning, our pre-harvesting stage, these are the points what I want you people to have a note of. So parameters of soil, you can use this as a small project, students, a various parameter, how well you can sense the soil parameter, and your small project should be able to tell now the soil is ready for farming or not. As simple as that. Okay. Similarly, the seeds quality. The better the seed quality, better the yield. Everything starts from the seed. So how well it germinates, how it happens, which particular place you have to apply the fertilizer. Anything has to be removed from that place. The pruning operation, genetic and environmental condition. So all this individually, parameters of soil, identification, prediction, and then getting the result itself is a research area. So like this, we have many tasks in pre-harvesting. Right? Sorry. Very sorry. Yes. So, fine. So, when it comes to the pre-harvesting, as I was mentioning, if you suppose take the soil, okay. So, when I have the sensors fixed to the soil, okay, I'll be getting many data from the sensor, the soil temperature, as I was mentioning just now, okay. So, all this data, when I receive through the sensor, what are the different algorithms I will make use of? Suppose imagine you have already handled with your, you're done with your algorithm selection, you have done with your pre-processing. Okay, pre-processing is taken care. So all these algorithms can be used. And these algorithms in the rigorous survey, what I have conducted, and when I interacted with people who are already into the research, I got to know these many algorithms are considered to be the best among the all. I'm not telling these are the only algorithm, but these algorithms are expected to give the best result comparatively. Okay, they've really given very good result. So in common, if you see for all these operations, you will be having our neural network. So neural network is considered to be the best now. So either our artificial neural network or a convolutional neural network. So if you see, we have extreme learning machines. the support vector machines, you have qubit regression model, neurofuzzy model, and the perceptron. The multi-layer perceptron and radial basis function is a one which is very commonly used in order to do the predictions with respect to the soil. So once we receive all the data from the soil, I can build an artificial neural network, okay, which has multiple layers of neurons in it, and specifically the activation function, what I choose for the neuron, that's very important for me in order to get the prescribed result. So these algorithms, I'm giving you a highlight of all the algorithms, what can be used. If you have to go very much in depth into it, I think we can go on with another session, wherein exclusively for these techniques also, we can have one session. Right now, you will get an overall idea of all the algorithms, everything that can be used. So the moment I apply these algorithms, I develop a model, right? So how it is going to help me? First and foremost, it helps in minimizing the extra cost that will be dumped for the fertilizer, and soil analysis experts are not needed. You are going to provide a model with a very good algorithm to the farmer, automatically they'll be getting the analysis. Obviously, the profit will be increased and the soil's health is consistently monitored. So the soil is being monitored continuously and it's very easy for us to maintain. Okay, so these are all the algorithms, right? Similarly, with respect to seed germination, same algorithm cannot be used everywhere. We can have multiple algorithms that can be used. Fine. So for example, if you take the seed germination, as I was mentioning now, how well a seed, the quality of the seed, how good a seed is and how well it germinates determines our final profit over there. So in order to carry over this, the seed itself can be examined, right? And then we can identify whether the seed is perfect for the germination process and what other things has to be supported over there. So again, we have our convolution neural networks, which can be used in order to process that data. And we have our multi-layer perceptron, again, the deep neural network. KNN is nothing but K nearest neighbor, right? And the logistic regression models we have, and we have our surf algorithm. So all these models can be used in order to take the data from the seeds, whatever input data from the sensors, process it and immediately tell which all seeds are of good quality, and obviously whichever is not good, we are going to reject it and just concentrate only on the good ones. So it is almost like seed segregation. For that process also we have models. Yes. And we have our pre-harvesting works and the disease reduction. So for this, as I was mentioning, what all tasks we have our extreme learning machine algorithm, artificial neural network, convolution neural network, navy-based, and K-nearest neighbor. So all these can be used in order to predict the disease of any particular crop, or whether the plant or any part of the crop is affected with the disease. And as I was mentioning, here we concentrate more on precision agriculture. This is where precision agriculture comes into picture. How perfectly we are going to tell that this is a disease which is existing in this particular location, and here is where the insecticides has to be sprayed over, right? So all these algorithms can be used. And for harvesting, as I was mentioning, all of you will be wondering, harvesting is just like, removing the crops, plucking the fruits and as such, but it's not like that. There are so many parameters which will determine whether that particular crop, right, or the fruit or the flower, whatever it is ready to be removed. So for example, if you see the fruit or the crop size, the skin color, the texture, the taste, the quality, how mature, the stage of maturity, how well it is grown now, and the current market window. This is very, very important. I can harvest now, keep it, but it's not like I can push everything to the market. I need to do an analysis over there. So this fruit detection and classification for harvesting itself is an individual research work. So you can start working on small projects. You can try to collect the parameters of the fruit. Usually what we do is the fruit parameters, we try to collect it. We try to train our model. Train the model using the algorithms, what I mentioned on the right hand side. So these algorithms can be used in order to train the model. What is happening when we are training the model? We are trying to inform the machine. When the fruit is of this particular texture, this color, all these parameters are satisfied, you can go ahead and you can just remove that particular fruit. You can harvest that particular fruit. So that is called as a training. When I tell orally, it sounds so simple. It's not so easy to train a machine. because a machine needs, converting a machine to think like a human is not so easy. So you have to feed in much training examples. For example, minimum of some 1,000 to 1 lakh data has to be fed into a machine. You have to keep on training the machine, keep on telling if these are the parameter value. For example, fruit color is like this, the texture is like this, all this is like this. If these are the values alone, you go ahead for harvesting that particular fruit. So fruit detection and classification. Detection using this parameter and using this algorithm, the machine will get to know, okay, this fruit is ready. Classification means ready or not, whether it can be harvested or not. So all this training has to be done. Then our model will be ready for putting it live into the real-time farming, right? So these are all part and parcel of our machine learning. Yes. So as I was mentioning, post-harvesting, very important, the shell life of the fruit, how well we are going to protect the fruit, right? Whether there is any problem in the place where it is being stored over there. And while harvesting, to what extent we have lost the crops. That is also very important. Okay, whether there was any loss in that, and improper packaging, all this needs to be taken care. Okay. Yes, so this is the overall machine learning process. So what all I mentioned now comes over here. So first and foremost, we have our data set, the input data. As I was mentioning, the input data has to be processed appropriately. Okay, we need to process it. We need to collect all the data and see to that whether all the data is of the particular data type, right? And unwanted data, we need to remove it. Redundant data, we need to reduce it. So all this will be done in that data set. Once we collect all the data, we need to process it. That is called as a pre-processing. Here I've taken an example of an image to mention about the pre-processing. So as I told, the images of the soil, the seed, the fruit, and the weeds, everything will be captured through our machine, right? And the pre-processing will be done. I'll be taking the image of a complete field that is not needed for me. From there, I have to literally scale down, come to my particular location. In that, whether it is a crop or not, everything I need to identify. So in order to process that particular, extract the parameters and everything, I need to go ahead with feature extraction. What are the features? As I was mentioning now, the color of the fruit, okay, the texture of the fruit, and the quality. These are all called as the features. When it comes to the soil, whether the soil texture again, okay, to what extent the soil is ready for harvesting now, the weather condition, whether soil erosion will be taking place, lot many things. So all the parameters what we use for prediction are called as the features. So I need to be aware of what are the features that has to be extracted in order to be fed to my model. So the next step is, after extracting all these features, I'll be feeding it into my machine learning model. So it is over here where my algorithms come into picture. So what all algorithms I mentioned till now with respect to what work I'm trying to do. If I'm working with respect to soil alone, it's a different algorithm that can be used. If I'm trying to check the quality of a seed, different algorithm. If it is related to pre-harvesting or post-harvesting, different set of algorithm. So all the algorithms will be coming over here. My machine learning model, nothing but a simple system which is trained in order to do the precise task. Okay, expected task is going to be called as a model. How do I train it? Through my algorithms and the input data. So my machine learning model, I try to develop it. And few people, they try to come out with their own models. That also happens. They don't take the existing ones. They don't consider, even when it comes to the neural network, they try to come out with their own number of perceptrons, activation functions, the layers, everything. And when it comes to convolution neural network, they take a call. So these models can be developed also. You have your Keras models, okay, not many tools which can be used in order to develop your machine learning model. So all these parameters are fed as input to the machine learning model. So what is the result? What do I expect from my machine learning model? What I expect is nothing but the classification or the prediction. So prediction in the sense, precisely telling like what are the parameters now, okay, whether the field is ready for harvesting or not. That is my prediction. When it comes to classification, whether I can go ahead with something or not. Is it ready or not? Is a fruit ready for harvesting? Is a crop ready for harvesting? Is a seed ready for germination? Means it is of a good quality or not? These all falls under my classification. So based on this particular classification and prediction results also, I can go for deciding, taking a call upon what needs to be done or not. Finally, what is very important is evaluating the model. So the moment we have developed a model, as I was mentioning, we cannot tell the model is going to be very perfect 100%. And next important thing, we cannot create one single model for each and every field. That's practically impossible. So I need to develop a model which can take the input from different sources, but it should be able to do the prediction for any type of field, any particular crop in that way, right? So evaluation of the model is very, very important. Again, I have to make use of certain metrics through which I can go for evaluating the model. Based on the performance, then we go for releasing these models into the market. So this is how the full machine learning models get developed. Okay, so these are the various steps. So as I was mentioning from the very beginning, each and every step can be taken as small projects. For example, the feature extraction step, identifying what are the various features itself is very challenging. If we don't identify the features, the parameters properly, we cannot train our model. We cannot blame the model, telling like model has not done the prediction. No, if our input data and the features are perfect, then our algorithm will automatically work appropriately. So each and every step is very important. You can start with small real-time projects. You can try to collect real-time data from the farmers or people who are working over fields. You can try to fix some small sensors over there. Do at least a soil prediction. Okay, do at least a seed prediction. Like this, we can start developing small models. Later, if you try to give a figure to that particular thing itself will become a robot. Just with 2 cameras, you start working, try to give an outlook for that. You can call it as your own robot. Why not? So this is how the whole thing works. So what is basically needed is the input data, very important, the parameters of the features. Next one is a perfect algorithm. How you choose the algorithm, right, for your model. Next important thing is a training. How many input data, multiple varieties of data you give to your machine, and how well you train it. That's very, very important. The training factor, all these decides your machine learning model, whether it is perfect or not. So since I've introduced the word about training, I wish to highlight, might be all of you are aware of it. So we have different types of training. We have supervised, unsupervised, and reinforcement learning. So in supervised, we ourselves mention to the model, we tell the machine, if the features are like this has to be the output. That will become supervised. Unsupervised, we allow the model to learn on its own. We feed in lot much data, we feed in the parameter, we allow the model to try to analyze the parameters, the values in various input data, and the model takes a call. The model tells this can be put into one particular group. These all data can be put into another group. So that is unsupervised. Reinforcement, based on the performance of the machine, we try to give some credit. If it is perfect, we appreciate it. If not, we ask the machine to rework. So that is your reinforcement. Similar to how a human gets trained, the same way we need to train our machine. As simple as that. So yes, so this is a whole ML process. So what are the various challenges faced? As I was mentioning, if you are able to address to any of these challenges also, great, amazing. You are right to be grabbed into any particular, ML or AI industry. You are ready for it. So first one is data set creation, wherein our big data analytics comes into picture. Suppose imagine I'm dependent upon the satellite images for weather prediction. Right? I'm just not using some simple sensors. I'm dependent on the hyperspectral images. So through satellite, I'm going to get the hyperspectral images through which I have to do the weather prediction. Believe me, dear friends, that itself is an individual task. It's an individual research area, individual model. A weather prediction system itself is a machine learning model. So it's like multiple models has to be integrated in order to carry out this task. So how well we go for our data set creation. So for example, this weather prediction alone, I try to get from the satellite images. Next, soil. Next, the seed. Okay. Next, the weeds are there or not. The field size. X, Y, Z. So many things. So how perfectly I go for creating the data set. As I was mentioning from the very beginning, If the input data set is not perfect, you cannot blame your model for the performance. How best is your algorithm? The best algorithm, if you choose also, the input data set determines its precision at the end. That metric is determined over here. So you need to have a clear-cut idea about what you're trying to do, collect the data set appropriately, integrate. See to that the data types are taken care and you integrate the data appropriately. Next important thing is the training and testing part, as I was mentioning now. At times it so happens overtraining and overfitting is also a problem. What is meant by overfitting? For example, I take, as I was mentioning, okay, one particular seed alone. For example, an apple plant. Okay, I have trained my model to predict the things related only to an apple. Okay, to apple plant. So only for that particular seed. This is like overfitting. That model will work very perfectly with respect to apple. The moment I introduce that machine, that model into a farming system where I have it's like an orange orchard or something, it's going to fail. So we cannot, that's what I was mentioning, we cannot have an individual model for everything. One-on-one is next to impossible. So that training part, we should be very careful. You shouldn't go for overfitting the model, neither it should be like totally below the expected level. It cannot have too many errors. So we need to set a balance over there. That is again a challenge. Okay. And next important thing is how much time you spend for this training and testing. If you're going to take too much time for training and testing, train the model to the best, okay, don't even deploy it in real time. It's going to get very difficult. So real time application of the model and fine tuning the model then and there is very, very important. Okay, the errors needs to be handled. We cannot tell the model will be error free. No, the errors needs to be handled, and how quickly the model can come out of the error, how quickly you can fine tune and refine the model is a real challenge. Okay, next important thing is the hardware support. So for example, if the hardware support and the whole model is going to cost way high for the farmers, then they actually put in for this agriculture process, no one would even get into this. They won't entertain. They will never feel like they got something out of it. It will be sheer loss for them. So we need to take the hardware support, the sensors, basically your Internet of Things, how well you interconnect the various components. All the components are needed, hardware is needed, but at the very minimal cost. So how cost effective or cost efficient model you develop is the next important challenge. And the fourth one, very, very important is, we know very well we'll be having lot many sensors, our algorithms. For example, if you take your convolutional neural network, all these algorithms, we cannot tell it's everything can be fitted into a small chip. That's not possible. So to some extent, the devices are going to be big, but how well we deploy this, okay, how well we take care of that portion, how well we can deploy the various sensors and machines without losing the sensors or the devices over there, how you fit it beautifully in a board, make it very handy. Next challenge. The last but not the least, the user awareness. So it's very easy to develop a model at some point of time. If you see, if you keep on working, you can make use of best algorithm, best input, pre-processing, everything is taken care, your model is ready. But how far the user is aware to use that model, that is the greatest challenge. So if they don't know to use that model appropriately, they are not able to predict, like get to know like what the machine is telling, how to, it's almost like an interaction. The user has to interact with the machine, of course, through our GUIs, agree. But how efficiently they understand it and how they interact with the machine finally decides the whole success of your model. So the user awareness is also a challenge nowadays. So these are all the challenges which we need to bear in mind before we go for developing a machine learning model in order to handle our whole agriculture process. Yes. So the last one. So whether we are completely ready for it, whether AI can replace the whole knowledge of the farmers, can we hire a particular field and put some robots there and expect the robots to take care of the field completely and just see to that my account is filled? No, we have not reached that particular point still. Okay, not to that extent currently, not, but in near future we are expecting all budding people, budding engineers and youngsters like you have to work more on this field, right? We need to minimize the errors. We need to improve the precision. We have to come out with very good models and missions which would literally replace farmers. Okay, we don't want to burden farmers anymore. We want farmers to sit at home, okay, in a very relaxed manner, have the machine, just a small computer, a device in front of them, which tells them beautifully what is happening in their farm. It is going to take care of everything. Our what to tell, driverless tractors, our robots, everything will take care of things, and they're just going to get the yield. It's not too far, dear friends. It's in a very nearing future. But now we are facing several challenges. So all of us unitedly, we need to work for it and, develop multiple models which can be used in our smart agriculture. Yes. Yeah. So thanks for the opportunity. So I'm ready to take up the questions.
All right, thank you very much, Dr. Varalatchoumy, for the very, very interesting presentation. I have a little bit background knowledge about this technology, and then it's very exciting in future, especially for agriculture, right? So I can see there's a lot of things that we can do with artificial intelligence and machine learning. And then yeah, the future is so bright, as long as we know what to do and how are we going to achieve for that. Okay, so for questions, again, to the audience, if you have any questions, please feel free. You can type on the chat. You can unmute yourself and ask directly to Dr. Varalatchoumy. And so if you're shy, you can just type, and then I can read it for you. So we have two questions, one from Facebook and then two in the Zoom. So I believe I'm going to read one from the Facebook first. So the question was from Associate Professor Dr. Sri Intan, our Dean. So yeah, basically she asked if there is any possibility for us in the faculty to work together with you in any like remote project, maybe something, because currently the students are doing their final year project. So is there any possibility we work together, right? Even though it's so far away, but is there any way we can work it out?
Wonderful. Thanks a lot. Because recently I was discussing with Dr. Krishnan sir also regarding this same. Our institute, Cambridge Institute of Technology, we are pretty much, we want to interact with several colleges. We want to have an inter-college interaction related to R&D. We are pretty much open for it, and we welcome all universities for the same. And in fact, we are already collaborated with several industries. For example, Saint Gobain, Infosys, IBM, all the industries we are working with the R&D projects, and we have linked with few other foreign universities also. So it would be a wonderful opportunity for us also and we'll be really welcoming, and we're very happy to collaborate. And yes, looking forward. Please do drop a mail and contact, and let us take this forward. So both the university students can work together in several projects. Not only that, even if few students are interested to pursue their research also, they can get all guidance from our end.
Okay. Yeah, I think we have your email, and then after this, we're going to drop you an email for further discussion. Thank you.
Sure.
And then another question we have from Muhammad Fauzan. We're asking a question in Zoom. How much efficiency? Is it 70% is enough of the algorithm to be working properly?
Yes, beautiful question. I think student has already started serving the papers and done some project. Then only they can answer this question. Good. Usually when we take all ML algorithm, especially when we develop our own model, as I mentioned in between, if we are trying to develop our own model, wonderful dear, you will be able to get only 70% max to max. Okay, we can start with that 70 or 75% accuracy. When we develop as a model in a very small, say for projects, or to develop as an initial testing machine, okay, a basic model, the alpha model we used to say, for that it is to some extent okay. But when it comes to reality, when we are trying to deploy it as a real-time machine, it's not that acceptable, because 70% accuracy, not only in this, suppose if we take our healthcare systems, there are a lot many domains where ML models can be used. So in any domain, the moment we take a model with efficiency or accuracy between 70 to 90%, the immediate response what we get is, why do we need a model for this? We ourselves can take care. Why do we need a model? When you're telling this is the error accuracy over there, we can take care of it of our own. That's very true. And the support system, what they expect from our model, the public, that's correct. We cannot deny it. We cannot deny the fact telling 70% you rely upon our model, 30% is left to your knowledge. So in the suppose initially you're developing a model, you're learning something new, we are training it, accept it. But gradually we need to see to that the efficiency should be increased. Okay, we have to push it at least to 95% to market it.
Okay, very interesting. And then you also said something about training. You talk about reinforcement training, and then you said that if the machine did something right, we give it a reward. What kind of reward can we give a machine? If human, we can give like foods, like gift or presents. How do we reward machines?
Okay. In reinforcement learning, it's not like a gift what we give to the machine. It is just a points. Okay, we try to tell whether it is correct or wrong, just like a feedback system from the user. So if suppose a machine predicts the things correctly in reinforcement learning, the machine needs some guarantee from our end, right? From the developer, the machine should get to know, yes, it's moving in the right direction. That particular prediction is correct. Immediately we approve it. As simple as telling it is right. And compared to, if suppose I have around 600 instances, okay, 600 input data, out of 600, if it is able to predict around some 500 or something properly, we give a particular scale. We tell the efficiency is to this level, is agreed. That model can go ahead. We are approving that the particular prediction made by the model is correct. If not, we try to rework. We try to change its way of thinking, and we try to make a better prediction.
Okay, so is it, correct me if I'm wrong, is it can we equal this, for example, when we watch YouTube, or when we listen to Spotify, and then when they predict the next song and then we like it, so we click love or like. So is that the example of reward to the machine, saying that you are predicting this correctly?
No, I'll tell you. Wonderful question. And this is something what I wanted to share with many of my students also. We are being, all our data is being, it is being tracked at the back end without our knowledge. That is what is happening in the machine learning. The best example, what I have taken, even in our online shopping websites, even though for the very first time we log into any online shopping app, very soon we get notifications, right? Very soon we get notification telling these things are available at this cost, immediately go. They literally see to that through the notification, you are pushed to buy it. Until you buy it, they're not going to stop. The same thing in Spotify. The more frequently we keep listening to songs, the more frequently we click that particular song, we get a tremendous data, beautiful set of songs which comes. This is the actual data processing which is happening at the back end, the data analytics. They keep analyzing our data. So people don't need any permission to do that. When we log in, we click that user agreement. Hardly any of us would read it. All our data is being analyzed at the back end. So that is actual data analytics. That doesn't come into this reward or precision part. The model is already ready, which is working with our apps, be it our Spotify or YouTube applications or something. It starts working with it. But the thing is, like, our data is being analyzed without our knowledge. That's why we need to be double, triple careful before disclosing our data, our likes and dislikes, everything we put, right? So those things we should be very cautious. So once our model is ready, only this particular thing comes into picture. So that reward is slightly different from this option, what we choose here. This will be serving as an input for our model.
Okay. And then maybe one last question before we move to the next speaker. If there is small farmers who, when we share this knowledge with them and they become very excited, but the small farmers have very limited resources, for example, from financial aspects. What is the simplest or the most fundamental that farmers can do to start involved in machine learning in their farm?
more than I wish to change the question, like more than expecting the farmers to do, how best we can support them. We as the people who develop some ML models or something, we can train the farmers. First thing is they should be told like it is not something to get afraid or worried about. You know, giving them the confidence. It is not going to cost too much. If possible, we can develop multiple models also. Very low cost. I mean, very cost effective, very low cost model, high end models. We can develop different model, provide training and confidence to the farmers, and then they can start using it. That training is very must. If farmers are not trained to use it, that's quite natural, right? If suppose I'm introduced in a place where people speak a different language which I don't know, even though the language is so beautiful and people are so good and sweet to me, I won't get to know. I'll get afraid of that place. And it's not so easy for me to get adapted to that location. So this sort of training has to be provided for the farmers. And I believe that's a responsibility of us, we machine learning analysts and people who work with develop the model. We should shoulder that responsibility, is what I feel.
Okay, meaning to say that the farmers and the university and the institute have to work together so that everybody can achieve a similar objective. All right, thank you very much, Dr. Varalatchoumy, for the sharing session. On behalf of the faculty and the organizer, Faculty of Agro-Based Industry, again, we would like to thanks for your time and sharing. Thank you so much, Dr. Varalatchoumy.
Thanks a lot. Thank you.
All right, so that was a very interesting presentation, and I learned a lot of things from the presentation. I hope you do too. So the next session we are going to have Dr. Edvin Skaljo. I don't know if I pronounce his name correctly because he's from Sarajevo. All right, so I think Dr. Edvin Skaljo, is that right?
Skaljo, it's okay.
Skaljo, all right, okay, perfect. So, so Dr. Edvin Skaljo are going to be together with us for the second session. Before that, I believe I'm going to introduce him a little bit to our audience. Dr. Edvin Skaljo is an assistant professor in Department of Physics at University of Sarajevo, and he's going to talk about urban farming, cloud computing, and Internet of Things. I believe that cloud computing is not something too alien to our audience, as they are quite familiar with services, for example, like Google Docs, Microsoft Azure, and Microsoft Office Live. So even though different application, but the similar principle might be there. I hope Dr. Edvin Skaljo maybe can explain more about that later. And then Dr. Edvin Skaljo also is the head of Department for Access Network and Terminal Devices in Telecommunication Center Sarajevo for BH Telecom. So in Malaysia, BH Telecom is something like Maxis, Celcom, or DG is a telco provider. And Dr. Edvin Skaljo received his PhD from the University of Tuzla, Bosnia and Herzegovina, and involved in many high-impact projects, such as become the leader in Gigabyte Capability Passive Optical Network, or GPON, of Sarajevo, and also team member of Sarajevo Optical Ring Project. So I think without any further ado, I would like to give the floor to Dr. Edvin Skaljo for the presentation. Please welcome.
Okay, thank you. Thank you for the introduction. I will try to share my window. Are you able to see?
Yes, if you can make it into a slide view.
Yeah, yes, I will. Okay.
Yes, perfect. Thank you very much.
Thank you. Hello for everybody. Good morning from Europe. Good afternoon for Asia. My name is Edvin Skaljo, but this is in Slavic case we have a sh name sh, but I always use s. It is easy for the English character set. As you explained, as you introduced, I'm coming from Bosnia, working on University of Sarajevo, Professor of Electronics, also in BH Telecom, and this is very good and I want to share my experience and my knowledge about urban farming, about the connection this urban farming, about sensors and similar. Let me allow several definitions, few definitions. I saw in the previous case also started from this point. We know that we have a smart agriculture. We have a smart agriculture. It is refers us to technology like internet, sensors, location system, robotics, artificial intelligence on our farm. Ultimate goal is increase quality and quantity of the crops. Here is two main goals. Also, one term is IoT smart farming, where we employ a lot of IoT sensors in our farm, and we can make monitoring of this and make intervention when we need, or the intervention can be automatization process. And it allows us that we have monitoring from anywhere. And the third terms is precision agriculture. When we have a lot of observation and measurement, and after that we employ some machine like robot to do some job instead human. And here on this way we will save human labor and reduce cost of human, but it will increase price of complete system. Let's just to have an imagine. We can imagine a smart farm as a lot of machine which are connected with sensors or actuators, and it is connected. It is monitored or driven by smartphone or another device that is connected to internet, like laptop, like MacBook or something like this. And if we want to have urban farming, it should be moved to urban area, of course. For full understanding of what is urban farming, there is two ways. When farm is outside of urban area and man is inside, and another when both and man and farm is inside of urban area. Usually people think that urban area is urban farming. Urban farming should be in urban area, but it allows us a lot of possibilities, and in the case of large cities, we have to employ precision agriculture if we want to have outside farm outside of urban area. Another discussion should be where is urban farm located. Usually there is two ways: on the top of the building, or on the some room for like a button, like basement, underground. So we can tell it is indoor or outdoor, but much more important is to have classification regarding daylight. It is very important. Does our farm has daylight or no daylight? If we know daylight, we might have to invest in lighting, and it will increase price of our farm. I will back to daylight on the end of presentation. Now I want to speak, continue my speaking about how urban farming arise. When we found ways that daylight has to be substituted by artificial illumination, it opened several possibilities. like a vertical in several layers fields, and on this way we save investment in the room and got a very cost effective room optimization, like farmhouse in our room can be several times more efficiency when we don't use vertical farming. Also, again, lighting will increase cost, and we have to carry. Another problem in urban farming is soil. In soil, I'm not someone who is who coming from agriculture, but I read that soil should be replaced every few years. It can be a big problem. It can be a big problem to move a lot of kilograms soil on the top of the building or the basement or underground. So one very efficient way is to change soil with water, and we can see especially in case vertical farming, water can be a very good, very efficient solution. Very efficient solution. Now, if we consider one small solution, like simple farm, where we have one water pump, take water from a reservoir and irrigate our plant. If we have exceed water, it will back again to reservoir, and it will cycle water will cycle. Of course, this is a very simple farm for our plants, no mind which type. But if we include several sensors, we can make this very cost effective. And for example, if we use just a sensor for humidity or water level, it costs several tens of dollars. We can make a big progress to save energy, to save water pump, and everything when can be controlled by small microcontrollers. Controllers like one Arduino, which you can buy for few dollars, and the sensors also are. But if we want to have employ a much more professional system, we have to include many sensors, different types sensors. And here I took from one paper. You can see this is a paper published last year. Here is PA sensor, EC sensors. This sensor monitoring quality of water and quality of soil. Then I need a light intensity sensor, humidity sensors, CO2 sensors is very important for indoor systems. If we have no CO2 sensors, it can be problem for men. Room can stay out without oxygen, and it can be problem. I mentioned the water level sensors, time sensors, LED lights. I will explain how we will use LED lights. CO2 automation, fogger on nozzle. Pressure pump, ventilation, air cooler, and warm air. All this I said this is sensors, but this is sensors and actuators. It means that we got information about our farming system, and then we have to do some job. We will do job, for example, activate the pump or fan or air or put CO2 in our room. Some of actuators can be expensive, and so it means that we need that we always need to carry about investment and what type of process we want to monitoring, to have monitoring, and which process will be automatization. Here is two example. Previously case is simple without almost any smart, and now we put inside a nutrient and put the water cycle around the root of our plants, and again we have to monitor all of this. I mentioned here that we have two sensors, two actuators, very interesting, optimization nozzle and optimization fogger, and it is possible to make this zergai spray and just put our nutrient on the root of the plant. Also, here is a lot of sensors. As you can see, sensors temperature, but we have to know that sensor of temperatures cost $1 or $2, and unless humidity sensors also likely, all these sensors cost just a few dollars. And on this way, pump is maybe a little bit expensive, but we is told that in our start system, we again also need a pump. We need pump. So here is one very efficient system which we can control again with one small microcontroller. But here is one, I found it, probably people from agriculture know about for this, but here is a very good idea to provide nutrient and O2, oxygen, by fish, and to have a fish tank with a lot of fish. Just we need feed our fish, and they will produce our very good water with nutrient and oxygen and we have a plant growing of plant, yeah. And again, as we can see, always we have the start system. Look, everything looks on the start system, and we just introduce several sensors. Of course, if we want this is a small. I explained the small farm system, but we need large systems. If we need a large system, then probably one microcontrollers cannot manage it with this. And then we will introduce a cloud server. And cloud server, however, we need to have here is a small local control for some processes, and again we will monitor nutrient inside of water, level of water, temperature, and everything. Collect this information here is in sensor service, send it to cloud service. It will be fastly proceed, and then it will give order to actuator service, and then we will, for example, stop pump or fast introduce stop lighting or put large light in our system. Also, as I explained, we can put here one microcontroller, and maybe it can be controlled. But if you imagine that it is very large with lot of sensors, then proceeding of this information, we have to include a cloud service. Of course, cloud service allow to us that we can monitoring this stack, for example, in another building, in another part of town, or outside of outside of urban area. So we can make a very good process optimization with cloud server, and to save our investment. Here is a user interface where we can get, for example, act and to get our information on a smartphone. On a smartphone, we will in that case we will be connected on the cloud service and to have all process on our smartphone. Okay, now let's this I explained. This is not so expensive if you add several sensors, microcontroller. We will get very efficient system. And if we have a lot of if we have a lot of urban farms, we will then connect it on cloud, and again to get a very efficient system. But if you want to go far and we want precision agriculture and to employ robots, I will explain how it looks in case of tomato when fruits going from unripe to ripe stage, and we can see here several tomato. And to find optimum ripe stage, what's happening here? We will take this photo. We will take this photo. It can be from some robot. Then to make white, black, and next step is put filter, where we put one threshold, and all strong black points will stay, but close to white will be deleted, and we will get like this here, and it will be moved. It can do average student of software engineering, and we will have tomato should be dropped, and here is one coordinated system, and on the easy way, our robot will find this and pick up it. There is, of course, there is question: is it too expensive? If we have a large, I really don't know and have no experience. Price of robot is every day is drop and drop. This line is less and less. Here is, you can see camera proceed this photo. I explained this, and now is question what camera will do. Again, if we have a process which I explained previously slide on this, here we have to have a small computer and proceeding can be expensive. So here is idea. Here is idea again is go to cloud computing, and this process move to cloud, and it will be easy and fast proceeding. This 3 pic photos. One I took from internet, another 2 I performed online on the internet on some web page. I forgot which one. So I didn't use any software which I have to pay. Just send online and got this photo. and photo in the same way. In the same way, robot when pick up a photo, it will send to cloud and return. Again, here is the main question: is robot too expensive? Do we need a so high precision? Here is one strawberry, and who will pick up a strawberry, robot or a man, or here is woman, or who will pick up it depends of your business case. On the sometime many things are as a hobby. Some people likes to pick up strawberry, and it relax him. But some people likes robotics like me, and this relaxed me if robot pick up strawberry. And in both case, hobby is one of driver of implementing urban farming. Here is I explained it previously case. Of course, we've got photo. I put here like boys, but it is a photo from it is a camera from robot. If some information can be proceed here inside of robot, but however, most of them will go here. What is here is important that we have very good internet here, that this photo or video or photo go to cloud computing where it will be acceptable, and proceeds and return information like the order to some actuators who will pick up or not, or move to the next tomato plant. So I will here is conclusion that we must find what can be done performant immediately inside of our urban farm, or what should be connected to cloud. In the beginning, I mentioned that I mentioned that the daylight or substitution for daylight is very important, and let me allow several slides about daylight to understand this. Here is a spectrum of sunlight, where we can see that we have visible light, infrared light here, and ultraviolet from sun. This is three types of lights coming from sun. We can see just here, just this light, visible light, and here is wavelengths of visible light. And next research went to see when light drop on the leaf, some of this light will be absorbed, some of this light will be reflected, and what type of light will be reflected, we are aware because we can see green color. It means that the green color is reflected, because we we cannot see blue. It means that blue is go inside of a leaf. The same is with red light. Here is also I found one research you can see on the bottom of this presentation, where they make experimental experiment and found that infrared light almost is completely reflected here. So let you know that LED light LED light is less expensive than, for example, daylight. Provide daylight to provide daylight, and LED lighter has a narrow spectrum, and we will focus it here. So it means that we don't need provide to our plant complete this spectrum, this part of spectrum. And of course, we will. Our idea is to save energy and to save money. Of course, here is also interesting, where we can see that the ultraviolet is absorbed, not reflected. For example, in a case of infrared, is reflected. Okay, the next research said that all light is not absorbed the same. For example, we can see that blue is much more better absorbed by a leaf of lung than red light. What now? What we can conclude and what we can do. For example, we don't need to use green color. We don't need green color. If we imagine that white light have blue, green, and red in the same amount, then it means that we will save 30%, 33% of energy because we will not use green light. Also, we can reduce blue light. Why? Because blue light is much more efficiency is absorbed than red. And typical we use three red light and one blue. And create something like lighting system like this. We can see here 3 red and 1 blue, and again 3 red, 1 blue. On this way, we will save additional almost 25% of energy. And summary, we will save more than 50% of energy for lighting. It can be very critical moment for our investment. And if we save 50%, here is two opportunities or conclusions. One, we can use LED lighting. LED lighting is very LED is very energy efficient, much more than all the light system. And then we can use specific like red and blue, and on the market you can find a lot of systems like this. And maybe I'm close to finally slide. You will be able to see at the bottom of my presentation that all research are very young. It is year or 2 or 3 years old research, and research in lighting is very attractive in the last time, and it will not finish it. And we can expect additional news from this. And on the internet, I know something about this. For example, if you are use a red light, then your plant will grow, become taller and taller. if you use blue, then it will be thicker. Then it stop it in growing, but wide. Plant will became wide and wider. And here is one very interesting research where said in the beginning we need just a red light, red light. So it means that we will additional save energy. In the next stage, we will use red light and blue light. During flowers bloom, we will use just red light, again red light and blue light, and in final stage, we will use just ultraviolet light without red and blue. On this way, our plant will get exactly light which they need. Exactly light which they need, and we will get a cost-effective system. It looks usually you can see on the internet a lot of examples where you can see here is three. One is red, blue, and high. This is for ultraviolet. For ultraviolet. On the bottom, we will employ examples from previous slides, and can get very effective farms inside of our cities or inside of our building, and it offer us to have, for example, here in Bosnia we have a cold winter and warm summer. During winter we cannot have anything in our farms, but if we have lighting by LED, we will be able to have and we are able to have farms, crops from farms during whole year. In my conclusion, smart agriculture opens a lot of opportunities. The cost efficiency of each farm is questionable, and you must everybody have to carry about investment, but good things is because you can grow step by step, introduce one by one sensors, and finally employ robots. Designer needs to consider what type of process should be automated, and here is on the top of my building, I have one small farm system, and this is a really good for relaxing hobby, and I'm engineer of electronics and doctor and professor. I really enjoy to monitoring how growing my plants and fruits and similar. Okay, here is the references. As I told, you can see that all research are very young. This is 5 years, several years old, and we can expect more news, fresh news, attractive news in this field. Thank you for your attention, and if you have a question, you are welcome.
All right, thank you so much, Dr. Edvin Skaljo, for the presentation. Yeah, we have one question from Facebook, or I'm going to read it for you. In Bosnia, does your company provide the technology or services for the cloud server, and how efficient is the service for urban farming compared to non-urban farming?
Unfortunately, not. Not. We have a lot of cloud systems still, but my opinion, all cloud systems are not fully employed. And this is in the beginning. Maybe the first started in my company. I'm not so sure. 2015 cloud system for IoT. And if you are monitoring if you look in the IoT, then IoT system can be implemented anywhere and in a farm, but still is not so it is not so developed. And this maybe this is a reason why I think this is very attractive, and I started to research in this field.
Okay, I don't know. Maybe if you can share with the audience, because the majority of audience are in Malaysia. If you can share with us where is the current state of adoption of IoT farming and auto urban farming in your country?
IoT farming is not, as I explained, is not so big, but this is in the start and as you saw, this is just in the research stage. Here is and if for example on my faculty I want to have one, but if I missed to start on autumn when I start year, then I lost complete year, and I cannot. You cannot make research in IoT farming for like I will start now, and for 10 or 15 days I will get results. You must wait complete year, almost complete year to have the first results. So IoT farming is not developed so much in my country.
Oh, okay. So because for example, okay, we have one question from Dr. Nufaiz. How about energy usage with the application of IoT in urban farming in terms of cost, electric and consumption?
Yeah, in the Bosnia, electric energy is not so expensive, but it can be a problem for the future. We will expect, we can expect that energy price will arise. And at the moment it is not expensive, but we have to care about this. And I explained, for example, that the lighting system spend a lot of energy, and I had one research where one saw that if you use the typical classical lighting system, you cannot get effective, cost-effective case. Cost-effective case. This is the reason why you might have to use a LED system with a red and blue light, and then save energy. So smart employing smart systems in farming and cloud, we will save energy, a lot of energy, and absolutely you don't need to start pump if, for example, humidity is enough and no so big temperature. You don't need use many things, and smart system is a way to save energy. Without smart system, you cannot make a cost effective. Maybe now in the Bosnia, because we have cheap and electrical energy. It is in Bosnia, and because we have a lot of water and close the European Union, and our export is based on the electrical energy. But we might have to carry about globally. Globally said that an electrical energy price will arise, and it arose 2 months ago, very few times more during the winter in the European Union. Mm-hmm. So my answer with employing sensors, microcontrollers, and cloud, we will drastically reduce consuming of energy of our systems.
Mm-hmm. So basically, urban farming is more towards like domestic use instead of commercial use now, right now.
Yeah, commercially, commercially request. I'm not so sure will bank support this. As I explained, here is no so big experience with smart farming, urban farming, because we don't know what will happen. But now is everything's changed. We know that globally food price of food arise and everything will be changed. So my think is that we have to this moment finalize our research in this field and focus on the economical feasibility of this, to see what's happened with the global price of food, and it will unfortunately it will improve possibilities to get cost-effective smart system. And my advice is for everybody, if you have space, should start with a small farming system and to see what will how much money will enter to your system, and how much you will get back.
Yeah, I think the future is getting better, because as you mentioned just now, the cost of sensor, for example, is decreasing. Just a few years ago, I still remember that one sensor can cost hundreds of dollars, and now you mentioned is very cheap. And the same thing with the LED lighting as well. I still remember last time it costs a lot of money, and then with the current development and so on, the cost is going down. So I believe that maybe in the near future we are going to see more and more of urban farming, or like greenhouse closed system structure being developed in more countries in the future. So yeah, I believe it is going to be a bright future as well for urban farming, especially in terms of land, land scarcity, competition with urbanization and so on and so forth. Okay, so I think that's all for now. If there is no more questions from the audience, I would like to take this opportunity on behalf of the Faculty of Agro-Based Industry, University of Indonesia Kelantan, to thank our speaker, Dr. Edvin Skaljo, for your time and for your sharing session. So before we end, I would like to take a group photo. So maybe everybody can switch on your camera, so for memory, right? Because it's not every day we can have two speakers from across the globe, right? All right, so you can switch on your camera. I'm going to take the photo. All right, I'm going to count 1, 2, 3. 1, 2, 3. One more. 1, 2, 3. All right, so thank you very much again to our speaker, Dr. Varalatchoumy, and also Dr. Edvin Skaljo, for your time. So I wish you have a very nice day, and assalamualaikum, and have a very good day. Thank you, everyone.
Thank you, and assalamu alaikum.
Wa alaikum salam. Thank you.